Hello everyone, welcome to my channel. So in this session, we'll basically discuss about the top Java interview questions for 8 years of experience of software testing person. And these are some of the questions that we'll talk about. First question is, what are the main principles of Java object programming? The main principles of Java object programming are encapsulated in four concepts. What is encapsulation, inheritance, polymorphism, and abstraction. These principles help in designing software that is modular, reusable, and maintainable. Encapsulation is basically helps in data hiding, which maintains the internal workings of an object, and these are hidden actually. Inheritance is a mechanism in which a new class inherits properties and behaviors from an existing class. Polymorphism means it's in many forms. It allows objects to be treated as instances of their parent class, thus enabling them to take a different forms or behaviors. While abstractions is a concept of hiding the complex implementation details and showing only the essential feature of the object. We'll go to the next question. Explain the concepts of encapsulation, inheritance, and polymorphism in Java. Encapsulation is a bundling of data and the methods that operate on the data into a single unit known as class. The use of access modifiers, public, protected, private, controls the visibility of attributes and methods. Inheritance is a mechanism in Java that allows a class, subclass, or derived class to inherit contributes to inherit attributes and methods from another class, while polymorphism means many forms and thus allows objects of different types to be treated as objects of a common type. In Java, polymorphism can be achieved through method overloading and method overriding. These concepts are fundamental to Java programming, and basically it plays a crucial role in building robust and maintainable object-oriented systems. Moving on to the next question. What is the difference between abstract class and interfaces in Java? Abstract class and interfaces are both mechanisms in Java for achieving abstractions, but they have some key differences in their implementation or usage, such as abstract class will always have a keyword abstract, while interface will have keyword interface. Abstract and concrete methods are the mostly used methods, while interface basically will only have abstract methods, that is default before Java 8, default and static methods from Java 8. In terms of fields, abstract can have instance variables, interface only can have public, static, and final fields. Constructors, in terms of constructor, abstract class can have constructor, interface cannot have constructors. Abstract class are basically single inheritance, while interface can have multiple inheritance. Abstract class can be any access modifier of methods and fields. Methods are public in default, and fields are public static final by default in case of interface. The basic purpose of abstract class is to share common behavior among related classes, while interface, the purpose is to define contract by implementing classes must follow. So in summary, abstract classes allow you to define a common base class with some shared functionality and leave certain methods to be implemented by subclasses, while interfaces define a contract for classes to implement, specifying only the method signature without any implementation details. Additionally, a class can implement multiple interfaces, but it can extend only one abstract class. So moving on to the next question, how does Java achieve multiple inheritance? Java achieves multiple inheritance through single inheritance. Basically, it is a class that extends only one class. Multiple inheritance achieved through inheritance where a class can implement multiple interfaces. Default methods introduced in Java 8 allowing interfaces to provide default implementation. Conflict resolution, it is handled by overriding methods in implementing classes and specifying only interfaces default methods to use if necessary. By using interfaces and default methods, Java provides flexible way to achieve multiple inheritance without the complexities associated with multiple inheritance in other languages. So basically, Java does not support multiple inheritance in classes, meaning Java class cannot directly extend more than one classes. Thus, decision was made to avoid the complexity and ambiguity that can arise from multiple inheritance, such as diamond problem. However, Java does support multiple inheritance of interfaces. This means that a class can implement methods multiple interfaces, each of which can define a set of methods that the classes must implement, thus allows for a form of multiple inheritance in Java, but only of interfaces, not classes. So moving on to the next question. What is the purpose of super keyword in Java? A super keyword in Java is used to refer to the immediate parent class of the current class. Okay? It serves several important purposes in inheritance, allowing a subclass to access members, method, fields, and constructors of its superclass. Here are the primary uses of super keyword. Calling superclass methods uses super.method name to call a method from the superclass. Accessing superclass fields use super.field name to access a method access a field from the superclass. Invoking superclass constructors. They use super arguments to call a constructor of a superclass. The super keyword is an essential play of Java inheritance mechanism, allowing subclass to leverage and build upon the functionality of their superclasses. It ensures proper initialization and provides a means to explicitly access superclass members when needed. Thus, using super helps in maintaining the clarity and explicitness of the code when dealing with inheritance, allowing you to distinguish between parent and child classes members or constructors and providing a way to access or invoke them when needed. Next question is explain the difference between method overloading and method overriding. Method overloading and method overriding are both mechanisms in Java that involve defining multiple methods with the same name but different parameters or implementations. However, they are used in different contexts and have distinct characteristics. So in summary, method overloading involves defining multiple methods with the same name in the same class, while method overriding involves referring a method in in a subclass with the same signature as a method in the superclass to provide a specific implementation. Method overloading is determined at compile time based on method signature, while method overriding is determined at runtime based on object type. Next question is what is constructor and how it is different from a method. Constructor in Java is a special method that is used to initialize objects. Unlike regular methods, constructors are called when an object of a class is created. They set initial values for the object's fields and perform any other setup required for the object. Some of the key characteristics between constructor and methods are basically a purpose. Constructor is used to initialize the object, while method is used for performing operations or actions on objects. Constructor must have same name as a class. Method can have any name and usually reflects the actions it performs. Return type. Constructor does not have a return type, not even void. Method must have a return type, example int, void, or string. Invocation. Constructors called explicitly when a new instance of the class is created using the new keyword. Method called explicitly on an existing object. Inheritance. Constructor not inherited by subclasses, but the subclass can call a superclass constructor using super. Method. Inherited by subclass if they are not private and not final, they can be overridden. Overloading. Constructor can be overloaded, meaning You can have multiple constructor with a different parameters list. Method can also be overloaded with different parameters list. So in summary, constructors and methods serve different purposes in Java. Constructors are used for initializing the object, while methods are used for performing tasks or operations on object. However, they both share similarities in their syntax and structure, as they are both defined within the classes. Next question is, what is the difference between final, finalize, and finally in Java? In Java, final, finalize, and finally are three distinct concepts with different meanings and usage. Finally, the keyword usually used to apply restriction on classes, methods, and variables in Java. Okay, well, that means a class, when you apply final in a class, that cannot be subclassed. If you apply final in a method, it cannot be overridden. If you apply final in a variable, value cannot be changed once assigned. While a finalize is a method that may be called by garbage collector before object destruction. It is used to clean up before an object is garbage collected. Finalize is not recommended for general use due to unpredictability and performance issues. Finally, finally is a block that follows try-catchy blocks. It is used to execute important code such as resource cleanup regardless of whether an exception occurs. So in summary, final is a keyword used for declaring constants, preventing inheritance, or providing method overriding. While finalize is a method used for performing cleanup operations before an object is garbage collected. Although its usage is discrete, finally is a block used, used for cleanup operations on releasing resources in exception handling, ensuring that certain code is executed regardless whether an exception is thrown. Next question is, what is the role of this keyword in Java? In Java, this keyword refers to the current instance of the class in which it is used. It has several important roles and uses. For example, distinguishing instance variables. This helps in differentiate between the instance variables and parameters with the same name. Constructor invocations. This can call other constructors in the same class, facilitating constructor chaining. Passing the current objects. This passes the current object as a parameter to other methods or constructors. Returning the current object. This returns the current object from the method, useful in method chaining. Accessing outer class methods. This refers to enclosing class in an instance nested classes. By using this, you can write clearer and more maintainable code, ensuring that references to instance variables, constructors, methods are unambiguous. So overall, this keyword in Java is used to refer to the current object instance, providing a way to access instance variables, distinguish between local variables and instance variables, pass the current object as a parameter, and invoke other constructor within the same class. Next question is, what is synchronization in Java and why is it important? Synchronization in Java is a mechanism that ensures that multiple threads can safely access shared resources. When multiple threads attempt to access and modify shared resources concurrently, it can lead to inconsistent data or race conditions. Synchronization helps to control the access of shared resources, ensuring data integrity and consistency. Basically, it refers to a coordination of multiple threads to ensure that they access shared resources in a safe and consistent manner. In case of multi-threaded programming where multiple threads execute concurrently, synchronization is crucial to prevent race conditions, data corruptions, and other concurrency-related issues. Some of the key points about synchronization is thread safety, monitor critical sections. Why is synchronization important? As I mentioned, it maintains data integrity, consistency, and avoid race conditions. Hence, by employing synchronization mechanism effectively, Java programmers can ensure that correctness, reliability, and performance of current Java applications. Next question is, what is serialization and deserialization in Java? Serialization is a process of converting an object into a stream of bytes so that it can be easily stored in a file, sent over a network, or otherwise transmitted as a sequence of bytes. Serialization allows object to be persisted, transmitted, and reconstructed later, potentially on different platforms or in different environments. Whereas deserialization, on the other hand, is a process of converting the serialized stream of bytes back into an object. Deserialization constructs the object from the serialized form, allowing it to be used again in the program. To make a class serializable in Java, a class must implement the java.io.serializable interface. This is a marker interface, meaning it does not contain any methods but indicates that the class can be serialized. So overall, serialization and deserialization is basically converting an object into byte stream and byte stream into an object when you want to deserialize the process. Why is multiple inheritance are not supported in Java? Multiple inheritance, where a class can inherit from one or more superclass, is not supported in Java. The basic reason is diamond problem. As mentioned earlier, multiple inheritance can lead to the diamond problem where the compiler cannot determine which superclass implementation to use. Complexity. Supporting multiple inheritance increases the complexity of language, both for the compiler and for the developers trying to understand and maintain the code. Favor composition over inheritance. Java promotes the use of composition over inheritance to achieve code reuse. Thus, through interfaces and composition, Java provides more flexible and manageable way to reuse the code. Interface-based inheritance. Java offers inheritance which provides a way to achieve multiple inheritance of the type through interface implementation without the complication of multiple inheritance of implementations. So to address the need for code reuse and polymorphism, Java favors composition over inheritance and provides mechanisms such as interfaces, abstract class, and delegation. Interfaces allows classes to implement multiple interfaces, achieving the form of multiple inheritance for behavior without the issues associated with multiple inheritance instead. This approach encourages better code reorganization, flexibility, and maintaining and maintainability while avoiding the pitfalls of multiple inheritance. Next question is very important. Explain the difference between hash map, hash table, hash map, tree map. Hash map, hash table is basically an implementation of map interface in Java. It stores key value pairs. Similarly, hash map and tree map are both implementation of map interface, but they are different underlying data structure and characteristic. Now, the hash map and hash table are thread safe but are slower. Hash map is synchronized, meaning it is thread shaped for use in current environment. All its methods are synchronized, ensuring that multiple threads cannot modify it simultaneously. While hash map is not synchronized in default, meaning it is not thread safe. However, you can make a hash map thread safe by wrapping it up using collection synchronized map. Okay. Similarly, hash map, tree map both are used for key value pair storage, but hash map is unordered and faster, while tree map is ordered and suitable for range queries and maintaining order. So in summary, hash map and hash table are similar in many respects, but hash table is synchronized and does not allow null key values, whereas hash map is not synchronized and allows one null key and multiple null values. Whereas HashMap and TreeMap both implement the map interface, but they have different underlying data structures and provide different guarantees regarding ordering and performance. So these are some of the basic Java questions that um, an 8-year experienced person of QA can expect in the interview. So I hope it was helpful this session. Please subscribe my channel. If you like the video, please hit the like button. Thank you very much.